Hi, this is Dr. Eddie Morgan over at Clovis East High School, and we want to work on our homework help for homework 1.7. Today in this homework we're going to be solving inequalities. And there's really only one extra thing you have to do. You solve inequalities exactly the same way you solve equations with one exception. If you ever in solving it multiply or divide by a negative number, then the inequality sign switches. It's one of those unique things. I know that 5 is greater than 2. But notice if I multiply them both by -1, -5 and -2, which one's bigger now? Well, now the -2 is bigger, and notice that my sign switches around now so that -5 is now less than -2. And if you look at that for a moment and see what's happening, it's like when you multiply or divide by a negative number, it causes the number line to just flip. And everything that was bigger is now smaller. So keep that in mind as we go through these. That's the only difference in solving inequality. Notice our first problem looks like a two-step equation, but there is an inequality sign here. So we just have to be careful if we ever multiply or divide by a negative number. Other than that, we do the same thing. In a two-step equation, the first thing we do is undo whatever is added or subtracted to the variable. In this case, there is a +7 added to the 4x. Notice I could rewrite this as simply 4t plus 7 is greater than 31. That's the same equation, and that would make it clear to you what we're doing. So the undo the +7, we're going to subtract 7 from both sides. And the reason we can do that is the subtraction property of equality. So 7 minus 7 is 0, so I'm left with 4t on this side is greater than 31 minus 7 is going to be 24. Now we undo 4 times by dividing by 4. And I asked myself the question, I just divided by a number. Did I divide by a negative number? No, it's a positive number. So that means my sign stays the same. T is greater than 6 is our answer. And by the way, we could do this because of the division property of equality. Okay. On the next one, now we have an inequality and it has a less than or equal to sign. But again, because of the inequality, we just have to watch out whether we ever multiply or divide by negative. So let's start off thinking about it like a two-step equation. The first thing we do is undo whatever added or subtracted. So 9a is subtract 7. So the first thing we want to do is undo the minus 7 by adding 7 to both sides. -7 plus 7 is 0. So I have -9a is less than or equal to 27. Now if I'm looking at this as a two-step equation, how do I undo -9 times a? I undo that by dividing by -9. Again, we got to get rid of the negative. So that leaves me a there, and over here it leaves me with -3. But we asked the question, did I divide by a positive or negative number? I divided by a negative number. And whenever you divide or multiply by a negative number, the sign changes. So less than becomes greater than or equal to. That's our answer. Our reasons up here that I didn't write in as we were going. This was the addition property of equality. And this was the division property of equality. All right. Our next one, just like before, we need to sort of straighten things out. First step is always to look on the left and the right side and see if we can simplify anything. Can't simplify anything on the left, but on the right, we can combine like terms, 7 plus 2. So let me write that out here. 5 minus 3n is less than or equal to 7 minus 2 is 5, 5 minus 2n, and we did that because we simply combined like terms. So we simplified both sides. Now we want to get the variables on both sides. Well, the negative 3n is less than negative 2, so let's undo the negative 3n by adding 3n to this side, and whatever we do to that side, we have to do to the other side. So we end up with 5, this goes away, is less than or equal to 5 plus n. All right? So now we're going to undo the plus 5 by subtracting 5. And that gives me 0 on this side, and 0 there is n. And we have 0 is less than or equal to n. This is, by the way, this we used was the addition property of equality. And what we did here was the subtraction property of equality. And now we have here 0 is less than or equal to n. Now, we usually don't, even though the answer is correct, we usually like to have the n on the other side. And you just remember a simple thing. If 3 is less than 7 and I turn them around, well, now 7 is bigger than 3. So when you flip the equation inequality, the sign flips with it. That's the old trick of the alligator. The alligator always wants to eat the bigger number. It's going to eat the 7. And so if you flip it around, the alligator just turns around and follows the bigger meal. So in this case, we're going to turn these around, n and 0, and so less than becomes greater than. And that is our answer for number 3. Number 4, once again, we begin by looking at both sides and just simplifying any that we can. The right side's okay. But the left side, we're going to use the distributive property to get rid of the parentheses. So we've got negative 4 times x minus negative 4 times 2. Be careful here, I have a minus times a minus. And this stayed the same. So I have minus 4x, and minus times a minus becomes plus 8 is greater than 6 minus 5x. Now we want to get all the variables in one term. Well, negative 4, negative 5. Negative 5 is the smallest, smaller than negative 4. So let's undo minus 5x by adding 5x. So negative 4x plus 5x, that's 5 minus 4 is 1x, plus 8 is greater than or equal to 6, and that went away just as we wanted it to. So now we'll undo, and by the way, this is, up here, this was the distributive property. Second step here was the addition property of equality. And now we're going to use the subtraction property of equality. So we subtract 8 from both sides. That goes away, and we have x is greater than or equal to negative 2. There's our answer. 6 minus 8 is negative 2. Number 5. Number 5, you notice again, look at left and right side. The right side's okay, but we got to do some work over here. First of all, let's get rid of the parentheses with the distributive property. So the first thing we're going to do is the distributive property. So we have 2 times a minus 2 times 3, or minus 6, minus 5a is less than or equal to minus 4. We still can simplify here because we can combine like terms. 2a and minus 5a, so let's combine like terms. And we get 2a minus 5a is negative 3a minus 6 is less than minus 4. All right. Now it kind of looks like a two-step equation, although it's an inequality. So we're going to undo whatever is added or subtracted to the variable first. So the opposite of subtracting 6 is adding 6. That will get rid of that, and we have minus 3a is less than or equal to 6 minus 4 is 2. So our next step is to divide by the coefficient of the variable. So we're going to divide by -3. And that's going to give us A on this side and -2/3 on the other. Now let me come up and make a mention up here. In this next step here, we combine like terms, and then we did the addition property of equality. And here, of course, we did the division property of equality. But we have to answer, because it is an inequality, the moment we multiply or divide, we have to ask ourselves the question, did I divide by a positive number or a negative number? In this case, we divided by -3. So because we divided by a negative number, this has to switch, and less than becomes greater than or equal to. And there's our answer. A is greater than or equal to -2/3. Number 6 again, lots of work. We need to first simplify on the left side and then simplify on the right side. So let's start with the left side. First of all, if I take away all these parentheses, this is like a negative distributing. This is like -1 times all of this. So I'm going to have 15, and negative times 12 is -12k. And then a negative times a -2, though, is +2. And notice I've kind of distributed the -1 to get rid of the parentheses. On the other side, we have 3 times k, 3k, plus 3 times 3 plus 9. Now we're still not simplified on the other side because I can combine terms. 15 plus 2, and so combined terms, 17 minus 12k is greater than or equal to 3k plus 9. Let me put my reasons in here. The first step here, we were simply doing the distributive property. On the second here, we were combining like terms. Now, our next step in solving this, now we've got the left and the right simplified. We want to get all the variables on one side. So I typically look for which coefficient is smaller, 3 or -12. Well, -12 is the smallest, smaller than +3, so we're going to undo -12k by adding 12k. And at this point then, this goes away, and I'm left with 17 is greater than or equal to 15k plus 9. Now we kind of have a two-step inequality. Undo the plus 9 by subtracting 9. 17 minus 9 is 8. 8 is greater than or equal to 15k. And now we're going to undo the 15 times k by dividing by 15. This is the division property of equality. And by the way, that was the subtraction property of equality. And so we're going to have 15, the 15 divided by 15 is 1, so we're going to have k here, and over here we're going to have 8 divided by 15. But we have to ask the question, did we divide by a positive or negative number? Well, we divided by a positive number, so that means I don't have to shift it around at all. And that could be my answer, but usually we don't want the variable on the right side. So we're going to flip them around. But remember, whenever you flip them around, the alligator's always going to want the bigger one. So 815 is bigger than k here, so I got to turn it around so it turns around that way. And that's the answer we want. K is less than or equal to 815. All right, similar again. We want to simplify the right side and the left side as much as possible. The left side is okay, but on the right side we're going to use the distributive property to get rid of the parentheses. So we end up with 21 minus 12a is greater than or equal 3 times 7 is 21. 3 times minus 3 times 4a is 12a. That was the distributive property. Now what we want to do is we're going to look at which one of the variables is smaller, and they're both minus 12. So what we're going to do is undo that by adding 12a. Now at this point you notice something weird's going away, because the moment I do that, my variables go away. And I'm left with this statement: 21 is greater than or equal to 21. Now I have to ask the question. I either have no solution, or I have an identity which is all solutions. So I ask the question, when is this true? When is 21 greater than or equal to 21? Well, some might go, well, 21 is never bigger than 21. That's true, but this is 20 greater than or equal. When is 21 equal to 21? All the time. So what we have in the end here, what we have is an identity, and our solution is all real numbers. It means you pick any number for A and that statement will be true. That's what it means. Okay, similar thing here. The left side looks fine, but on the right side we can combine like terms. So let's combine like terms. So over here I have 8m minus 5, and on this side 8 minus 2m is 8m plus 3. Once again, if I go to put the variables on one side, the variables are the same. So if I get rid of them on this side by subtracting 8m, notice again that both of my variables went away, and I'm left with this statement: negative 5 is greater than 3. By the way, up here I use the subtraction property. So the question is, when is negative 5 greater than 3? And if you think about your number line, a negative number is never bigger. So the answer to that is never. So our answer here is there is no solution. There's no number that you can put in for m that will make that statement true. All right, number 9 is a word problem. The student council wants to rent a ballroom for the junior prom. The ballroom's rental rate is $1,200 for 3 hours, plus $150 for each additional half hour. Suppose the student council raises $1,875. Now, if that's the most they can spend, what's the maximum number of hours? Well, we know that the rate, and we need to write an equation for this. We know that they can spend for 3 hours $1,200, and that's for 3 hours. Okay. Now, for every extra half hour, they're going to spend $150 times every extra half hour. So I'm going to let x equal additional half hours. I got to be a little careful here because I'm finding extra half hours. I start with 3, so my answer is going to be 3 plus the extra half hours. So we have to be careful there on that. I could have put down $300 times x and said x was extra hours. But my point here is $1,200 plus 150 times each extra half hour, and the most I can spend is $1,875. So my answer is this has to be either less than that or equal to that. It cannot be greater than that because I don't have that much money. All right? So let's solve it. We're going to undo first what's added to our variable part. So we're going to subtract 1,200 from both sides, which is another way of saying after we get done with this, we have $675 that we can spend for extra half hours. All right? So now let's undo the 150 times that, divide by 150. And I get x on that side. I'm going to use my calculator on this one. 675 divided by 150 equals 4.5. And notice that I divided by a positive number, so x has to be less than 4.5 half hours. All right? So they're not going to loan it to us. They want to know what's the maximum number of hours. Well, we're not going to get a half hour. So the maximum we can spend to stay under is 4 half hours. Well, how many hours is 4 half hours? Well, 4 half hours is 2 hours. Now remember, we got it already for 3 hours, plus the additional 2 hours means that the maximum number of hours we can rent it for is 5 hours. Okay? Someone might argue, well, we got an extra half in there, and maybe we can get another, half of that, half of a half an hour. Someone could argue that, well, if they'd let us, we could do another 15 minutes. But the answer is, what's the maximum number of hours? And so we're going to leave our answer in the closest hours. So 5 hours is our answer. Problem 10 is error analysis. Can we describe and correct the error in each solution? We have 3y plus y. Let's just work it here. Because often if you just sit down and work it, you can see where they make the mistake. Now, if I want to put both variables on both sides, now, although I'm looking at their end, first thing they did was get rid of the 5. So to undo the 5, they subtracted 5. And they have 3y is less than or equal to minus 2y plus 3. So we're good there. And now they said y is less than or equal to 3. Now, here's where they make the error, and I want you to see it. They said 3y, and they just go 3y minus 2y is 1y. But remember, you can't make that kind of adjustment across the equality or the inequality line. You have to say, all right, I want to undo minus 2y by adding 2y to both sides. And notice when you do that properly, you end up with 5y is less than or equal to 3, not y is less than or equal to 3. Now one more step, undo the 5 times y by dividing by 5. It's a positive number, so we don't have to change the sign. And the answer is y is less than or equal to 3/5. Error analysis on this one again. Let me do it over here, and we can follow along and see where they make their error. So the first step we need to do is do our distributive. So 4 times p, so 4p, 4 times 5 is 20, is greater than 3p plus 3. And notice the error right away. They forgot to multiply the 4 times the 5. All right? And so at this point, that's where the error is. So let's finish out the problem. They like to get rid of the numbers before the variables. I prefer the other way. So I'm going to undo this by subtracting 3p. And I get p plus 20 is greater than 3. And now I'll undo this by subtracting 20 from both sides. And I get p is greater than negative 17 is the answer. So their key thing was making that mistake on the distribution where instead of multiplying 4 times p plus 5, they only multiplied 4 times the first term and not the second term.